Thanks a lot for the invitation. The aim of the talk today is to give a brief overview of the Androit or Adroit6G project. This is the outline of my presentation, a brief overview, the objectives, innovations, the general architecture, the proof of concept, and some ideas for standardization. What Androit or Adroit proposes disruptive innovations in the architecture of emerging 6G networks. We propose fundamental changes, how networks can be designed and implemented, and how this will be done by adopting a fully distributed AI-driven paradigm with functional elements that are deployed on demand as virtual functions in either in cloud-native environments across far edge, and cloud domains operated from different stakeholders. We have 9 very well-defined objectives. First, proposing the novel 6G system architecture, defining AI-driven management, orchestration, and control framework for 6G networks, proposing distributed and secure crowdsourcing solutions, develop and deploy energy-aware models based on multimodal representation learning, evolve the cellular architecture in order to be able to integrate deep edge devices in the communication and computation functions, enable link with non-terrestrial networks to connect with the cellular architecture, demonstrate the use of decentralized AI for D2D communication, propose data plane acceleration, and then integrate all these solutions and demonstrate in well-defined proof of concepts in low TRN in lab-based scenarios. And how all this will be done? We have a consortium of 13 partners, 9 member states. We have 4 large companies, operators, manufacturers, 5 RTOs, top-tier research center and universities in Europe, and 4 innovative SMEs. We addressed the stream B0101 call. We're a project of the first SNS call. Our budget is around 6 million. The project ran for 36 months, and we started beginning of 2023. These are the main innovative concepts. We propose this AI/ML powered optimization, where we propose fully distributed artificial intelligence in the network operation, and we aim high performance and full automation of the network. We also have this cloud-native software where we implement across various edge cloud platforms, and we integrate security in this operation. Finally, we have this software-driven operation where we have zero-touch operation, full automation for the network and other delivered services. We can go through these different concepts, and I would like to explain you all these concepts. First of all, we shift to distributed AI. We transitioning of the standard centralized AI model to distributed one, considering federated and decentralized learning. We also propose the concept of crowdsourcing AI in order to provide domains and applications with optimal AI models. And in Adroit, we emphasize in energy efficiency, carbon footprint reduction, and secure AI ML operations. We also propose the concept of BDI agents as a concept to decentralize decentralized learning that's operable through edge cloud spectrum. Finally, we employ generative models for multimodal data for conserved resources in the network operation. regarding the transition from cloud-native software, transition to cloud-native software, we propose to modernize the cellular infrastructure to function seamlessly in cloud environments. We leverage the new concept of user equipment as virtual base station in order to facilitate far edge network component deployment. And we also consider edge cloud deployment and end-to-end in order to ensure seamless integration between cellular and satellite communications. We use also in the zero-touch operations adaptable models in order to predict and adapt the operation of the network based on the needs of the network and having some predictive models. And we transform management and orchestration into a fully automated solution. We distribute the MO functions and we employ distributed AI in order to have optimal closed-loop control of the network. All these concepts, for all these concepts, we have very well-defined innovation streams, and we propose specific solutions like the computer concept for UEs as a virtual base station, novel decentralized AI framework for D2D, crowdsourcing AI, focusing on carbon footprint, energy efficiency, learning representation of data collected at the edge and the far edge in order to have sustainable data usage, zero-touch management, enabling AI dynamic slicing configuration, and network automation and self-optimization via closed-loop orchestration. And this is our architecture. We have four main blocks. The infrastructure domain, where we split the infrastructure domain, we consider infrastructure in far edge, edge, and cloud, and three network blocks. The AI-driven management orchestration that implements the logic of end-to-end automated management of intercomputing and interdomain network infrastructure. The fully distributed and secure AI framework that provides the AI mechanisms for the framework, and the BDI driven unified and open control framework that is responsible for the real-time and the non-real-time closed loops for the network automation. We'll go through these blocks in order to show you how, which block more or less does in this architecture. Okay, no, sorry, here. The AI-driven management orchestration framework handles end-to-end automated management of the network infrastructure, features multi-tenant network slice composition across the different domains, coordinates slice subnet sharing, extend slice management for integrated public and non-public networks, and offers service-driven strategies for user plane function management at back. The fully distributed and secure AI framework for crowdsourcing AI provides all the necessary AI mechanisms to support management and orchestration. In this case, the case of this project facilitates energy efficient provisioning, AI model training, and discovery using meta learning. It also offers control frameworks that help to validate and refine the AI models, and then manages data distribution with secure information sharing and synthetic data set generation using the generation models. Finally, this BDIX AI-driven unified open control framework manages the real-time loops for the network automation, allocates resources dynamically based on the current conditions and the predictions based on some data sets, handles the resource congestions, scheduling, computational offloading, and oversees the BDI agents, their reconfigurations, and use as virtual base stations resources. All these solutions will be tested in a lab environment. We keep the TRL low to 4, and we have 4 POCs. The first one is about immersive XR, let's say holographic teaching. We have the teacher or the professor from home, from the office, while the students attending physically the class. Then the teacher can appear as an holographic entity in front of them. In this case, we test extreme EMBB service class. The second POC is about collaborative robots or cobots. We are in a construction area. We have robots and drones working together, and then we need to synchronize all the activities in order to avoid some conflicts. We also have a POC for terrestrial 6G IIoT in a production line of an automotive manufacturing process. We have sensors and actuators, and in order, all these sensors and actuators should take actions in sub-millisecond time intervals using the Adroit solution. And we also have NTN for low bitrate IIoT in an area of trackside IIoT devices and train terminals, where they send data to a remote cloud, and then we have this edge cloud, the far edge, all together working to provide the solution, the required solutions. We have very well-defined KPIs for each one of these POCs. Some of them are very challenging. We need to address them during the tests in the lab. We have as a baseline scenario the 5G KPIs defined from the previous framework. And we also have KVIs. We are trying to understand how these KVIs will be measured. We have defined some methodology, and I think this is also an open homework for collaboration with Hexa-X. We'll have some deliverables soon for this. Finally, we have identified some of the solutions, how some of the solutions can impact the standards. This crowdsourcing AI solution to minimize AI ML carbon footprint can create impact to the HCN working group. The closed loop automation AI-driven multi orchestration can or may create impact in the ZSM, in the HCMEC working group. The concept of UE as virtual base stations may contribute to the 3GPP PSA1, and the end-to-end integration with 6G solutions can go to the SA2 working group. That's all from my side. Thank you very much for the invitation.